All right, ready to dive in? Today, we're exploring the world where self-adaptation meets federated learning meets the Internet of Things. Specifically, we're looking at how we can boost AI without sacrificing data privacy. And let me tell you, the research paper we're about to unpack, mind-blowing. We're taking a deep dive into self-adaptive federated learning and Internet of Things systems. A review. Yeah, it's a mouthful. But trust me, this paper is important. It gives us a glimpse into the future of AI and what it means for your privacy. So imagine this. Your smart home, from your fridge to your thermostat, learns what you like and adapts to how you live your life, all without sending your personal data to some tech giant. That's the promise of self-adaptive federated learning in the Internet of Things. Pretty cool, right? To get this, we need to understand the two big players, self-adaptive systems and federated learning. Think about a chameleon that changes its skin color to blend in. That's kind of what self-adaptation is. It's like these systems are constantly adjusting, making sure they're working at their best no matter what's going on around them.
And the fascinating thing is that self-adaptation is super important in this world of connected devices. We're talking billions of devices in the Internet of Things, and keeping all of them running smoothly, even with all the complexity, is a real challenge. That's where self-adaptive systems come in.
Okay, so we've got these systems that can adapt on the fly. Now let's add federated learning to the equation. That's where data privacy takes center stage. Instead of all your data going to a central server, federated learning lets devices keep their data private and secure.
Exactly. Think about smartphones, each one packed with data about its user. With federated learning, those smartphones can work together to train a shared AI model without ever revealing their raw data. They just exchange tiny updates, like little pieces of a puzzle.
Okay, so we've got systems that can adapt on the fly, and we've got AI that respects privacy. Got it. But why should you, someone interested in all this, care about how these concepts work together in the Internet of Things specifically? Think about all the data your devices collect. Your smart speaker, your security cameras, even your smart lights. That's a lot of personal information. Right, with traditional AI, all that data would be sent straight to the cloud. And that's not exactly ideal if we're talking about privacy. Plus, let's be real, a lot of these devices aren't exactly known for their powerful processors or rock-solid internet connections.
And that's where self-adaptive federated learning comes in. It's like imagine giving these devices a brain upgrade. Now they can work together efficiently and privately. Think about getting hyper-personalized recommendations from your smart speaker, but your listening history stays private. That's the power here.
You've sold me on the why. It makes perfect sense. But how does it actually work in the real world? That example from the paper about security gateways in smart homes really caught my eye.
Okay, so picture your smart home, right? Everything's connected through like a hub, maybe a smart speaker, or a dedicated security system. Now that gateway, that's your FL client. It gets a basic AI model from the FL server. Let's say this model is designed to detect any unusual activity in your home. The gateway then takes this model and trains it using data from all those connected devices. Cameras, sensors, door locks, you name it. And here's the beauty. It all happens locally. That means your raw data, it never leaves your home.
Clever. But hold on. What happens if, let's say, there's a software update for your smart lock? Wouldn't that change how it usually behaves and maybe even set off a false alarm?
You're right, that's a really important point. And it highlights just how smart these self-adaptive systems need to be. In that situation, the system is actually smart enough to tell the difference between a change in behavior caused by a normal update and a genuine anomaly. Think of it like a security guard who knows when you're coming home late versus someone trying to break in.
So it's always learning and adapting, even as your devices get new features and you change up your routine. That's reassuring.
Exactly. That constant adaptation, that's what makes this tech so powerful. And listen, the applications, they go way beyond just smart homes.
That's what I was hoping to hear. The paper mentioned a few potential uses. What really stood out to me was self-adaptive FL in industrial settings. Can you tell me more about that? Industrial settings, it's like factories of the future, right? What can self-adaptive FL do in that kind of environment?
Exactly. Imagine a factory where AI can actually predict when a machine is about to fail.
Wow.
Yeah, that's the power of this tech in manufacturing. It's called predictive maintenance.
Yeah.
It helps minimize downtime and, of course, saves huge amounts of money.
Okay, that alone sounds incredible. What else?
Well, there's also supply chain optimization. So self-adaptive FL can analyze data from all parts of the supply chain. Suppliers, manufacturers, distributors, the whole nine yards. It can then optimize inventory, anticipate problems, really make sure everything runs without a hitch. And again, all this happens while keeping sensitive data decentralized and secure.
It all sounds really promising. But I imagine there are challenges too. I mean, developing these systems can't be easy.
You're right, it's not a walk in the park. One of the toughest challenges is designing those self-adaptation policies. The systems need to be adaptable enough to handle, well, anything, from small changes in your routine to major unexpected shifts.
So it's like trying to predict the unpredictable.
Exactly. And on top of that, reliability is key. We need these systems to make helpful changes, not create more problems, right? Plus, the Internet of Things is constantly evolving, with devices connecting and disconnecting all the time. That adds another layer of complexity.
I'm starting to understand the challenges. It's like leading an orchestra, where the musicians can just leave or join in whenever they want.
That's a great way to put it. But even with all that, self-adaptive federated learning has the potential to completely change how we use technology. It's about giving devices the power to learn and adapt while still keeping our privacy and security intact.
So, as someone who's clearly passionate about the future of AI, what's the biggest takeaway for you?
I think it boils down to this. The future of AI isn't just about creating smarter algorithms, it's about designing systems that work in our increasingly interconnected world. Systems that adapt to change, that learn from whatever information they have, and that can make intelligent decisions without compromising our privacy.
Now that's a future I'm excited about. Well, as we wrap up this deep dive, one last thought to leave you with. As these self-learning systems become more and more advanced, could they one day start making decisions for us, even in important areas like healthcare? Something to think about. That brings us to the end of another deep dive. Thanks for exploring with us.